Okay, so this is just some further clarification on these composite functions. So the homework has where you come up with an equation for the composite function. Some of them come up with the value based on graphs, some come up with the value based on tables, and the last kind is where they come up with the value based on the equations. So the first group I'm doing here is the composite function from the graphs, to show you how you do this. So really what you do to get this final answer, you first answer what is g of 4. So that means you go to the g graph, which is the one below here. You go over at x equals 4, go up to the graph, and you read 5. Then you evaluate f of 5, not f of 4. So sometimes you think, I'll use 4 in both cases, but you use the result of g of 4, which is y equals 5, and then you do f of 5. So now we can go over here to 5, and you go up to the y value, and it's 1. So f of g of 4 is 1. Okay, let's do another one. So f of g of 2 is something. So first we do g of 2. So we go over to g of 2. So here's 2, x equals 2, y equals 0. And then we do f of 0. So now we go up to the f curve and find out the y value at 0. So the answer there is 4. So that's the answer. So those are f of g of something. Now, if you want to do g of f of something, first you do f of 2. So whatever's in the parentheses. So we go to x equals 2, y equals 5 for the f curve. So that's 5. Then we do g of 5. So come down here, go to x equals 5. That's 1. So g of f of 2 is 1. And then finally here we do f of 3. So we come over here to f is equal to 3. Y is equal to, x is equal to 3. Y is equal to 2. So that's 2. So then we do g of 2. So we come over here to 2, and the answer is 0. And so we get 0. Now you can do this with the same function. So if I did f of 3, a composite function, first you do f of 3. So we come to the f curve, 1, 2, 3. F of 3 is 2. So then we do f of 2. F of 2 is 5. So the answer is 5. So we evaluate f of 3, which gives us the value of x equals, y equals 2. Then we use that y value in the same function. So then we use the y value as the x value in the next evaluation. And we do the same thing, g of 3. So we do g of 3. So go to g, which is 1, 2, 3. The y value is 4. So the second time we evaluate g at 4. 1, 2, 3, 4. So that's 5, and that gives us the answer. So that's how those work. Now from a table perspective, it's kind of the same thing. So, and this is the other way of evaluating or representing composite functions, is this looks like a little 0, which stands for of. So this is equivalent to f of g of 1. F of g of 1. So again, what we do, try to find the answer there. So we're going to do g of 1 first. And we go over to the table. So x equals 1. G is 0. So that's 0. So now we do f of 0. So we go over to our table 0, and the corresponding f of 0 is 5. So that's our final answer. Here we have g of f of 3 is something. So we do f of 3. So we come to our table here. F of 3 is -1. And then we do g of -1. So now we come to -1, read off the corresponding y value. So f of g of 3 is 0. Let me just move this over here so we get a little more space for all the answers. Okay, let's do this one next. So we have f of g of 2 something. So we're going to do g of 2. So x equals 2. G of 2 is -3. Then we do f of -3. So -3, we go to f, which is 11. Okay, next one is g of 1. So we do g of 1. Here's x, 1, g of 1 is 0. So then we do g of 0. So g of 0 is 1. So our answer is 1. And finally here we have g of f of 2 something. So we're going to do f of 2. Here's x equals 2. F of 2 is 1. We use that number. G of 1. So g of, let's make sure we did this right. F of 2 is 1. And then we do f g of 1, which is 0. And then finally we got this f of 3 is something. So we do f of 3. 3 is the x value. F of 3 is -1. And then we use that for the argument of the function. F of -1 is 7. So it's basically the same thing, except instead of taking our values off a graph, we're taking them off of a table. And the final grouping is to evaluate these composite functions. So let me just write out. The one in the book uses f of g of 0, so let's just do f of 1. F of g of 1. So we'll do both instances. So we'll do f of g of 1, and we'll do g of f of 1. So that's going to be some value. So instead of using the graph, we're going to calculate these values. So again, we're going to do g of 1. So we plug 1 into there, 7 minus 1 squared. That's going to be 7 minus 1, which is 6. And then we do f of 6. So then you plug 6 into here. So it's 4 times 6 plus 8. That's 24 plus 8, which is 32. So the answer is 32 for that part. Now over here we have g of f of 1. So we're going to do f of 1 first. So we plug 1 into this equation because this is the f function. So you have 4 times 1 plus 8, which is 12. 4 plus 8 is 12. And then you take this number 12, so you do g of 12. So now you plug 12 into the g equation. So you get 7 minus 12 squared. That's 7 minus 144, or negative 137. Okay, let's do the same thing over here. So we're going to do f of g of 1 and g of f of 1. So again, we do the internal one, g of 1. Here's the g function, so that's 4 times 1 plus 3, which is 7. Then use this number to evaluate the function f of 7. So that's 1 over x plus 2, but x is 7, so we get 1/9. So the answer here is 1/9. Because if I just did f of 1 would be 1 over 1 plus 2, which would be 1/3. But I'm doing f of g of 1. And over here we do f of 1 first. So that's 1 over 1 plus 2. So plugging in x equals 1 here. So I get 1/3. So g of 1/3, because this is g of f of x, so you do the f part first. So then you would plug 1/3 into here, so you have 4 times 1/3 plus 3. So that's 4/3 plus 3, which is 4/3 plus 9/3, which is 13/3. So that's the answer here, 13/3. So they all have the same format, and probably if you get that g of f of x with the little 0, it's probably just best to convert it. G of f of x, just change that to g of f of x, and that way we know that it's in the same format, so you can just remember one. Or if we did, g of f of 1, that's the same as g of f of 1. Okay, so give it a try for the homework problems.